Okay, so we're going to talk about section 1.5 here, which has to do with transformations of functions. And what I want to do is start out with a function, fairly simple one, and then using some sliders to investigate how these functions change, and then we will do some problems and talk about some more things. So what we're going to do is we're going to investigate f of x equals the absolute value of x. We're going to take a look at that. All right. So when it comes down to transformations of functions, you basically have what is called a parent function, all right, which is the function in a most basic or general way. All right. So what we wrote here would be called like the parent function, right? And then from the parent, we can do some transformations on it, and that then kind of becomes a child, so to speak. Okay, so this is our basic parent function. All right, and what we're going to do is go into Desmos, and we're going to use some sliders to investigate this. All right, so let's do that. Go ahead and go into Desmos. Okay, and we'll investigate that with some here. I'll show you how to set that up. So I'm just going to go, I think it's just go y equals, actually, yeah, let's just do that. So y equals a absolute value. So absolute value is right here. Okay, and we'll put an x in there. Oops. I want to put a b in front of that x. And I also want to put a parenthesis. So it looks like that. Minus, I'm going to put a c. And then I'm going to arrow past all of this stuff to put a plus d at the end here. So that's what it's going to look like. So it's y equals a, let me put this on a projection to get it clearer for you. Y equals a absolute value b parentheses x minus c parentheses absolute value bar plus d. Underneath that, it says add slider a, b, c, d. And we're just going to hit all. And now we have a slider. So what I want you to do is we're going to adjust b so that it's 0, c so that it's 0, and d so that it's 0. Okay. Oh, sorry, b is 1. There we go. So there's my absolute value function right there, nice V shape. Okay. And what we're going to do is, or what you're going to do is investigate each one of these parameters, A, B, C, and D. I wouldn't do them all at the same time because it's going to be hard for you to kind of see what's going on. But you can investigate them by just sliding that little ball here back and forth, okay? A little big point, however you want to think of it. Slide it back and forth. You can play it. If you hit this on the sides, you can play it and watch what it does. And then in a few minutes, we'll go over it, and you can kind of tell the substitute what it is that you noticed. Okay, so let's do that. So we'll pause this video and give you about 5-10 minutes to play with this. Okay, so hopefully you had some time here. You can see that I'm changing this to f of x. There we go. So what we want to do is talk about, well, what do these values A, B, and C, these parameters, what is it that they're doing to that absolute value function? Okay, so somebody should tell us what happens. What does A do to it? So hopefully, you paused it again each time we pause this, and maybe you're jotting some. Hopefully, Mr. Pettit is writing some things down, maybe for each one of these. So we're kind of gathering some ideas. Okay, that's kind of what I was hoping we would be able to do here. So A, all right, hopefully you have some ideas on what A does. All right, let's go back to Desmos here, and I'm just going to simply play it. All right, and I can see that V becomes narrower, right? And it becomes narrower or wider. And it also, we notice that it flips. All right, but we want to know, well, when does that happen? Okay, well, as A becomes larger, that V becomes narrower. And you might think, well, that's what's happening. But in reality, what's really happening is you're stretching it. Okay, so you're taking that function and you're stretching it vertically. So what that does is it allows that curve to become narrower. All right, so if we were to zoom out, all right, you can see that we could, I bet if we picked the right window, all right, we could get it so that it was a normal looking V, all right, but here we just have this tip of it. So if I go back to A is 1, okay, real close to 1, there we go. There's my normal one, all right, and if I was to just take a look at this portion of the V, I could change that window so that it was pretty close to the V that I have when the A value is higher. All right, so what it's doing is it's stretching that up. All right, I also notice that I have a flip going on, right? Okay, or a reflection, and that occurred as soon as that A value became negative. So here's what we have. All right, so A is a vertical stretch. So as A becomes larger, how about A increases? Let's do that. As A increases, the graph is vertically stretched. Okay, so we stretch that up, all right, as A increases. On the flip side of that, if A is between 0 and 1, say, okay, so it's like a decimal, then that curve is not necessarily stretched, but it's compressed. So if we had, say, y equals 0.5 absolute value of x, what that does is it widens that curve, but it's compressing it because this value is a scale factor, all right? That's what that's called. It is a scale factor. So that's how much it's scaled. So if we put a 2 there, that means that the curve has been vertically stretched by 2. Okay? And we can look at this. We'll put some numbers in and play around with it so you can see what's going on too. If A is less than 0, then we have a reflection over the x-axis. So these are the types of things you should have kind of noticed. It might be differently worded, and if the wording makes better sense to you the way you wrote it, then stick with that. You can combine the two here if you want, but we want it to be so you can understand it. All right, but that's what A does. Okay, let's try B. What does B do? All right, so let's pause that and get some ideas. Okay, so hopefully you kind of got some ideas. Now, many of you probably said, I think it does the same thing. All right, and it's pretty easy to say that. Let me get this back to 1 here. And as we move this, it says, oh, I think it's doing the exact same thing. All right. And that's true, except when we have a negative, all right, we're not getting that reflection, all right, in the x-axis, all right. But there is a reflection happening. It's just that I chose absolute value, which doesn't do a very good job of showing really what b does, but not many functions do, okay. If I was to use some sort of a sine or a cosine curve, then we would see what b does. All right, but in this case, it's kind of hard to see it. But what b is doing is it's taking this graph and it's stretching it, but not vertically, horizontally. Okay, so then we would say this is a horizontal stretch. All right, and if b is negative, then it's a reflection over the y-axis. Okay, so we have b is a horizontal. You just don't see it very well because this graph is symmetric, right? So it's hard to see that, okay? And like I said, we'll go through and play with some numbers and you'll kind of see what's going on. There's also another interesting thing here about b, but I want to play with the numbers first and then we can talk about that. Okay, let's get b back to 1 here. I want to move it back to 1. There we go. All right, now I'm going to come down here to c, okay? And what is it exactly that c does? Okay, we'll pause it again, gather some ideas. So hopefully you said c. If we slide c here, I don't know why it's not letting me, there we go. All right, we're getting this, what we call a translation or a slide, right? It's sliding. So a translation or slide, okay, horizontally. And I want you to put down c units because that is important, all right? If I make c 3, notice that that tip has moved over 3 units, okay? If I make the c a negative value, then it has moved back 3 units, okay? This, however, is somewhat confusing because if we look at the equations of these, say that, you might think, well, that's going to slide over horizontally 3 units. But in actuality, it doesn't, because if we go back to our original equation, which I did not write and I should have, there we go. Okay, that should have been written down there. We have a minus c here. All right, so that minus c messes us up a little bit. So that means that this would be minus a negative 3, right? Because we have a plus there. So this is going to go over 3 units negatively or 3 units to the left. Okay, so a lot of people just think of it as being just the opposite of what's inside there. So whenever you have a transformation and you have an x plus 3 or 4 or 5 or whatever it is, that c is actually negative, so it's going to move it in that direction. All right, so that's what a c does, is it translates it or slides its c units. Okay, last one. What about d? What does d do? So again, same thing. Let's pause it, gather some ideas, see what you find out. Okay, so let me get c here to 0. And we notice, oh, well, d is a slide too, right? Or a translation. Okay. but this time it's vertically. And that is also D units. Now on the D value, it's consistent because up here we have a plus D. So if D is a positive or a negative value, then that's how much it's going to move. Okay, so if I have a -2, then it's going to go -2 units vertically. Or down. Okay. So we can get all these things moving around here at one time, and man, it looks pretty crazy. All right, and I think you can even slow it down a little bit there by changing these. There we go. So it's slowing down a little bit. All right. There we go. Okay. Now the fun's over. All right. So that's what those transformations do. Okay. And it really doesn't matter which function it is. They're all going to do the same thing. So it's important that you kind of figure out the transformations and you do them. And you look at them that way. Okay. It makes your life a lot easier with dealing with functions. All right. So let's look at this from a different point of view. All right, let's just take a look at y equals x squared. So there's my nice U-shaped parabola, all right? And what I'm going to do is I'm going to build on some values here, okay? But I'm going to build on the values as I change this. So let's say I go a times f of x. What does that do, okay? So if I put a 2 in front, for example, here's x squared, and here's 2x squared. All right, so I'm going to pick 1, 2, 3, 4. Yeah, let's do some negatives actually. -1, 0, 1, 2, 3. Okay, I'm going to square those. And now I'm going to multiply them by 2 because that's what this says. Okay, so you're going to take x's, the x squareds, your input right here, right? Going to get an output here, that's your x squareds, but then you're going to multiply each one of those by 2. So when we graph this, all right, we have our normal parabola curve, okay? But when I do these ones, so 0, 0 is still the same. -1 is now 2, all right, and 1 is 2, and 2 is now 4, times 4 is 8, and then 3 would have been 9, but now it's actually 18, so you can see how you're getting that stretching action when you multiply it by the number, all right, so it's just stretching it out, okay, so that's kind of a numeric or table way of looking at it. Now let's do the same thing with this. Okay, same function, doesn't change. Okay, so now what I'm going to do is take a look at this. Oops. So I'm going to do that. Okay, which means that I'm going to take 2 times x and square it. So see, the function is x squared, but we want 2 times x first. So we're going to take whatever numbers we get here, all right, which would normally be squared, but we're going to 2x squared them, all right. So obviously this doesn't change, but when I do this, so I'm going to get -1 times 2 is -2 squared is 4. 0, that's just going to give me 0. 1, well, that's going to be 1 times 2 is 2 squared is 4. 2 times 2 is 4. 4 squared is 16. Okay, 3 times 2 is 6, so that's squared, that's 36. So this is our b value. Okay, so normally it's kind of like this, right? But now that I've stretched this thing, so -1 is like a 4. All right, 0, 0, 1, 4, 2, 16, way up there. All right, and 3, but here 3 is way up here at 36. So you see that that is just really becoming pulled. Okay, but it's being pulled or actually compressed horizontally. All right, because if we think of this horizontal, this one is actually wider than the yellow one is. All right, so it's kind of a compression. Even though you're multiplying by 2, you're actually getting a compression in the horizontal stretch. It's sort of an opposite or a reciprocal relationship. All right, if we do the same thing, but we do, say, 1/2 x, all right, then let me put that in here. So then that should just be the opposite, right? Let's see what happens. So -1, right? So I'm going to take -1 times 1/2. -1/2 squared, that's going to be 1/4. Okay, 0 is 0. This is going to be 1/4. 2 times 1/2 is 1. 1 squared, that's 1. 3 times 1/2 is 3/2 squared is 9/4. So when I do this one, okay, I got -1 and 1/4, so that's kind of small. All right, right there, 0, 0. Okay, and let's see again. 1 is like about 1/4, and 2 is 1, and 3 would be 9/4. So we're getting this really curve here that is stretched outward. Okay, outward horizontally. So that's why the absolute value looked like it was the same, because basically when you have these symmetric curves, you're not getting a lot of difference. It looks like it's the same thing, but in actuality it's not, because you're multiplying here, we're multiplying the input values and then performing the function. And on the other hand, with the other ones, we were doing the function and then multiplying them, performing the transformation on it. So it's a little different, all right? But this here, you would think, oh, that 1/2, you know, that's going to actually bring it in and compress it, but it doesn't. It stretches it outward. Okay, so it stretches it outward, kind of, because you got to think of it horizontally, not vertically. All right. If you have questions, ask, because it's kind of confusing stuff, right? Pause the video, watch it again, ask questions, do whatever you need to do. All right, let's take a look at the C value now. All right, so again, I'm just going to take this, and I think I'll put a -1 in there. Okay, so here's my table. I got x. I'm going to take x minus 1, right? And then I'm going to take that x minus 1, and I'm going to square it. Okay, so -1, 0, 1, 2, 3, using the same numbers. Okay, it's going to be a -2, -1, 0, 1, and 2. And now I'm going to square that. So that'd be 4, 1, 0, 1, 4. Okay, so x minus c, I'm looking at the c value. I just picked the value for c, negative. I picked 1. All right, here's my x values. I took x minus 1 because that's what I'm doing. And then I'm going to take that and apply the squared term to it. So then I'm going to take those numbers and square them. Now let's graph this. So we have -1 and 4, 0 and 1, 1 and 0, 3 and 4. Oh, I have 2 and 1, sorry. And then 3 and 4, so it looks like this. Okay, so you can see how it's been shifted over 1 unit and how the shift works. Right, because normally we'd have that curve back here. And if it's a +1, then that same thing happens, right? Except it's going to go backwards because it is a -1 that the C value is, where here the C value is this, okay? Because it's a minus. Remember, it's minus, right? So that means it's going to shift it over 1 unit, okay? If this is going to be an f of x +1, then what that means is it's going to shift over left 1 unit, all right? So instead of subtracting 1 from these x values, we're adding 1, which happens to shift it back in that direction, okay? So that's that one, all right? Last one, numerically. So if we have f of x, and then I'm going to put a d out here. So let's go f of x plus 2, for example. All right, I'm going to make my same chart here. Okay, so now I'm squaring and then adding, okay, because the d is outside of the parentheses of the f of x, not on the inside where it affects that x. The d is not affecting the x, it's affecting the output or the y. All right, so let's do the same thing. No use in changing now, right? Okay, so once we have those numbers, now we're going to add. So we can do that. Okay? So we're just adding 2. But notice that we add 2 after we do the operation here. So let's see. We got -1 and 3, so that's about there. I got 0 and 2, that's about there. Maybe not quite, but pretty close to right there. I have 1 and 3 again, and 3 and 11 way up here. So there's my curve. And like we would suggest, that's been moved up 2 units. All right. But you're adding the d value after you perform whatever the function is. And that's why it's being shifted up. So here, you've gotten to see it visually with Desmos. And here, you've gotten to see what happens if we add a table to it. All right. So, hey, look at these things again. And there's going to be a part 2 to this. So I'm going to save this and then we'll watch part 2.